Let's look at the even powers. So first, why do the graphs make a U shape at all? I think an example should make this clear. So 2 times 2 is 4, but negative 2 times negative 2 is also 4. So it's got the same magnitude, it's the same number, and the negatives canceled each other out because we multiplied a negative number by itself an even number of times. So you can see that that should hold true no matter what the exponent is, as long as it's an even number. So 2 to the 4th is 16. Negative 2 to the 4th is also 16 because you're multiplying negative 2 by itself 4 times, so all of the negatives. This also makes it clear why a larger exponent like 4 should grow faster after x equals 1 than a smaller exponent. So in other words, the bigger the exponent, the steeper the curve is. Because obviously multiplying 2 by itself twice is going to be a smaller number than multiplying 2 by itself 4 times. So the points on the graph will end up above the points on the graph of a smaller exponent. What may be less clear is, why is the larger exponent graph actually smaller in the interval from 0 to 1? Let's again do it with an example. So 1/2 times 1/2 is 1/4. But 1/2 times itself 4 times is 1/16, which is a smaller number. So the idea is, if you have a positive number that's smaller than 1, the more that you multiply it by itself, the smaller and smaller the result gets. But if you have a value that's greater than 1, the more you multiply it by itself, the larger and larger the result gets. So that's why you have this behavior where it kind of flattens out and then becomes very steep. And then what happens in the middle, of course, if you have an input of 1, it doesn't matter how many times you multiply 1 by itself, the output is always 1. Same thing for -1, because all of the negative signs cancel. So that explains why those are common points on all of the graphs, regardless of what their exponent is.